Hi, I'm Anita and I'm the maths exams expert. And in this lesson, we are going to learn about the factor theorem, which is really useful little shortcut for helping us to find the factors of cubic equations, to find the factors of polynomials, particularly cubics, and also we're going to learn how to solve cubic equations. So we're going to start off by learning how to do algebraic long division, and we're going to have a little throwback to your primary school skills there, and we're going to be using the same set of steps that you used in your primary school long division, but we're going to be applying them now with algebra. It's okay. I know you might have some PTSD from long division in primary school, but this is a set of repeatable steps that's quite doable once you've practiced it enough. We're then going to look at how we can use the factor theorem to shortcut this, but even though you can shortcut it, you can't always shortcut it. So you do need to be able to do the algebraic long division as well. Depending on the exam question, it might be set up in a way that you still have to do the long division. And we're going to look then at factorizing and solving cubic equations. We've been doing linear and quadratic for quite some time, but we haven't solved cubic equations yet. So it's time to get started on that. And then we're going to be linking that up with the roots of cubic equations. So here we go. First things first, algebraic long division. Make sure you've got a title on the top of your page. You're going to need to write these steps in here. We're just going to follow the steps over and over again. So this is set up as a fraction. And when we were doing algebraic fractions, we were trying to factorize the numerator and see if things would cancel, but we don't have the skills to factorize this yet. So instead of looking at this as an algebraic fraction, we're going to think about it as a division, because you know that line, which by the way is called a vinculum, that is the division symbol as well. And so we could set this up for division like this, with that bus shelter as it's sometimes called. Step one, divide in. Now, when I say divide in, it's only the first term of the outside that's divided into the first term of the inside, first into first. So divide in. 2x divides into 6x cubed how many times? 2 divides into 6 3 times. X divides into x cubed x squared times. Step one, divide in. Step two, multiply back. Now, when you multiply back by both. We only divided in the first, but we multiply back by both. So multiply back. 3x squared times 2x gives 6x cubed. 3x squared times -1 gives minus 3x squared. I'm going to pause for 1 second and point out a few things to you. When I did the divide in step, I wrote the 3x squared a little bit to the right. It's not a deal breaker if you don't, but it's just nice to have the x squared terms all lined up here. When I multiplied back, the 3x squared times 2x gave me 6x cubed, which is the same as the 6x cubed above. It always will be, and it must be in order for us to do the next subtract step correctly. So if it's not the same as the term above it, you've made a mistake. You've divided in incorrectly. All right. If 2x divided into 6x cubed is tough for your brain, another way you can say it to yourself is 2x times what gives 6x cubed. And think about it then. 2 times what gives 6 is 3. X times what gives x cubed. X times x squared gives x cubed. Right. Multiply back by both. I'm going divide in, multiply back. Next is subtract. So in order to subtract, I'm going to minus the second line, but I'm also going to put a minus in here, because if I don't, I'll mess up my signs. We're minusing all of the second line, so we need to minus each term, not just the first term. These will always cancel. 6x cubed minus 6x cubed is 0. They will always go away. They have to, or else you've made a mistake. Then we've got positive 5x squared minus 3x squared. If your negative numbers are catching you out, check it on your calculator. 5 minus 3 is 5 plus 3, which is 8x squared. That's the subtract done. Step 4, bring down. We go back up to the top and we bring down that minus 10x. That's that done. Okay. What do we do now? We cycle back up to the top and we repeat. Here we go. Divide in. When we're dividing in now, our 2x all the way down here divides into our first term down there. 2x divided into 8x squared, or if you prefer, 2x times by what gives 8x squared? Positive 2 times 4, x times x gives x squared, right? So we've done the dividing step, we need to multiply back. Remember, for the multiply back, we said we take this and we multiply it by each of the outside terms. 4x times 2x gives 8x squared, and it must be the same as what's above. And then 4x times minus 1 gives 4x times minus 1 is minus 4x. Just get rid of those there, we don't need those. So that's the multiply back step done. Now we're into subtract. Drawing our subtract line. Minus here and minus here. Don't neglect to put the minus over the second term. I see it so often that students think they don't need to do these little things that help your mind, and then they end up making mistakes. 8x squared minus 8x squared cancels, it goes away. Now I've got minus 10x minus 4, which is minus 10x plus 4, minus 10 plus 4 is minus 6x. That's the subtract. Now we're on to bring down. This term here comes down and it becomes a plus 3. Bring down. Back up around again we go. Rub out our ticks, ready to go again. Scroll down a little bit. Dividing. The first term, the 2x, divides into the first term down here. 2x divided into minus 6x is minus 3. Or 2x times what gives minus 6x minus 3. Divide in, done. Multiply back. Minus 3 is going to multiply by each of the two terms. So minus 3 times 2x is minus 6x. Minus 3 times minus 1 is plus 3. Multiply back, done. Subtract. Remember, with our subtract, we change the sign here and here. Minus 6x minus 6x is minus 6 plus x. Positive 3 minus positive 3 is 0. So we're left with nothing there. There was no remainder. Okay? So we can say that 6x cubed, when you divide it by 2x minus 1, you will get 3x squared plus 4x minus 3 with no remainder. Take your time. Annotations, anything else you need to get this sorted. When you do the example yourself, if you have never done these types of questions before, you're going to need to keep my word example in front of you and follow it through step by step. You may even need to do this next one with me again before you get the hang of it, and then you can go back to your textbook and do another bunch of questions. Here we go. All right, so that one was a little bit shorter, and you see you come to a natural end with this. One thing I want to point out to you just before we leave this section of the lesson is, if you don't have all the powers of x, so if, for example, you had x cubed plus 4x plus 2 divided by, let's take x minus 1 again. If that was the question you were doing, when you were setting it up, do you notice that there's an x squared missing? You are allowed to have x terms missing, but for your algebraic long division to work out easily, you really need to it's like place value, you need to fill all the spots. So because I don't have an x squared value, I'm going to put a little placeholder there by putting in a 0x squared plus 4x plus 2. And that will mean that you can follow your normal steps and it won't get messed up. You'll notice, I'm sure when you're practicing, you might get caught out with this where you forget to include that placeholder, that's 0x squared, or whichever x term is missing. It might be an x term that's missing or an x squared, and you'd put a 0 in that place. If you forget to do it, all of a sudden things will start to go wrong and you'll be not sure why. And it's because you need that. You need all of the places, the x cubed, the x squared, the x, you need them all represented in order for your steps to work out properly. I'll just write a little note here.